Hello, here in this video we're going to look at week 22 for our honors homework. It's also going to be a good review for our test. So let's go ahead and get started. Now the first section says I'll read the greatest common. Alright, so now when it says to factor out the greatest common factor, what we're looking to do is find out what is the largest factor that I can divide all of my coefficients by, all my variable numbers. And also, if there's but now I'm not going to be able to take out any m's because and the 14 divided by the 2 gives me a 7. So this is what greatest common factor is. And this is how we phrase it. Now remember to reading back out. We'll look at one like here on number 4. Now on this one, people have like Mr. Connell, I see we pull that out. It just depends on what our goal is. On this one, we go ahead and because they all have it. But like some of them don't. We usually try to make our first term positive. We haven't really gotten to the point yet of how to like discuss that. So at this point right now, it's as if you want to or not. We always want to make our first term positive. So this one, let's look at the numbers. I see a negative 40, I see a negative 20, and a negative 16. So like we said, we are because we usually try to make our first term positive. Now I'm looking at the 40, the 20, and the 16. I see they're all even. I divide them all by a 2. But I can also divide them by a larger number, perhaps, right? And that's going to be a 4. Right? 20 I can divide by 4. 16 I can divide by 4. So I'm going to factor them all by not just a 2, because that wouldn't be greatest factor, but a 4. All right, now I'm going to look through at my x's. I see that I got an x to the 4th, an x to the 6th. So if I try to take away the most is a 2, right? I can't take any more away than 2 x's from each of these terms, because this first term only has 2 x's to give. So we've determined here that we're going to be factoring out a negative 4 and an x squared. So we'll go through and do that on each of our terms. Right, so the first term, negative 40 divided by 4 is a positive 10. It had an x squared. We took an x squared away, so this 10 won't have any x's left with it. Move on to our next term. This negative 20 divided by this negative 4 gives me a positive 5. It had x to the 4th power. It lost an x squared, so it has 2 remaining. And then now our last term is the negative 16 divided by negative 4 gives me a positive 4. And there were x to the 6th power there. We took away 2, so they'll have. Alright, so when looking at these, remember, you're always trying to find the greatest common factor. What's the most amount that we can take away from everything? Alright, and so I'll give you a hint here on number 6. I'll tell you that the greatest common factor that we'll be able to take out is going to be, if I'm looking at it, is the largest number. I'm going to go ahead and make it a negative 6. That way we can get our first term to be positive. And now when I'm looking at my variable b, I see 2 and 1. So the most I'm going to be able to take away from everybody is a b. So I'll leave it up to you to go through and decide what happens if I divide all of my regular numbers by negative 6, and then I remove b from all of them as well. Alright, so on to the next section. It says factor completely, so that means we all split it up into its two different parenthesis pieces. But it also says to check for a greatest common factor first. Now, not all have a greatest common factor, 7 and 8. There is no number that I can divide everything by. I won't be able to take out any variables. We don't have a number with our variable squared. So what we're looking at, so when there is no 8, when there's no number with our x squared, add to give us b. So what are numbers that multiply together again? 1 times 2 and 1 plus. Remember, these are the ones that are a little bit easier for us. That's what we're trying to do. Looking for the factors of a positive 9 that add to give me a negative 2. So I see that 1 and 9 gives me a 9, 3 and 3 gives me a 9. Then I decide I need to have a negative 10 here, which means I'm going to need to generate. And the only way I can do that is if I turn both of these sets of factors negative, because negative 1 times negative 9 still gives me a positive 9. And also negative 3 times negative 3. And only one of these combinations is going to work. It is indeed our negative 1 plus a negative 9. So that's what our final answer would look like there, because we found our correct set of factors. All right, so if we take a look down here, always check for greatest common factor. We'll have a greatest common factor that we can pull out. These four here, we are going to have some numbers that we can divide out, so be looking for a greatest common factor. Divided by a 3. Right, so once we get it like that, the good news is it just made that problem a lot easier. And here's how we're going to set up our answer. I'm going to need to have the 3 on the outside still. And then we're just left factoring what's left over. Right, and it was an easier one, so I'm thinking about what numbers multiply together to give me a negative 6 and add to give me a positive 5. Like, okay, well, that is a positive 6 and a negative 1. And if you would have drawn up a table for this, you would have found that to be true. With the 3, the greatest common factor on the outside. Right, and then we have what's left over after I factor in n squared plus 5 and n minus 6. In either order, it could be a 3 times an n minus 1 and then an n plus 6. That would also still work. So some of these here actually turn into regular factors for us. Easier type once. Right, so on page 2 is difference of squares. And so we know that this whole page is a special case. It's telling us that ahead of time, so that's good. But remember, difference of squares is where we're looking for the perfect squares of our first terms, perfect squares of our last terms. Always having the setup of this. Right, where one needs to be positive and one needs to be negative. That's why it was called difference of squares. Positive term, one's going to be the negative term. So let's take a look at how. If you want to use could solve it as looking for factors of positive 9, factors of negative. These are our pattern recognition. Where I know to get a 9x squared. To get a negative 4, it's a perfect square. Doing a negative 2. Right, and that's what it would look like. So you could use this if you wanted to. But special cases here. It's of squares knowledge. So go through, it's just the perfect version of the perfect squares of the number on the end. Right, so even if we don't have a number out in front, it's still going to work the same way. X times x gives me an x squared. And I'll have a positive 1 and a negative. Because positive 1 times negative 1 gets us negative 1 here. Term does indeed cancel. That's why I needed one of these to be positive and one of these to be negative. But then it switches over to our perfect square type. And this is where we're thinking about a square. They have the same side length, so they have the same length and width. And so we had two different cases that could come up here. We had double positives, or we had double negatives. Right? And that all depended upon what side we saw here in the middle. Right, so there's special cases with our perfect squares. So we're looking to solve this like we were doing above, except this time we're not going to have or double negative. So 12 would work like r times r gives me an r squared. And I think of the perfect square of 25, just 5 and 5. Now the only way this 5 and 5 to turn into a positive 10 is if both of these are positive. All right, great. Negative sign. Like number 20 here. Now these problems do work with the table organizer if you like to do it that way. Right now, my perfect square for 1 is a positive 1 and a positive 1. But we know that since we need a negative here in the middle, I'm going to need to go negative 1 and a negative. And then see if we were to multiply these out, we realize that we do get from our original to understand where our middle term comes from. So I'll prove this to us. I'm multiplying this one out. So when we do our 4 terms, we have a 3n squared minus a 3n minus a 3n plus a 1. And when we put those like terms together, we do get right back to our original answer. Now, the remaining 4 here at the bottom, some of them could be special squares. Some of them could just be some regular factoring. Take a look at what we got here and see if you can't piece it together.